Hi, and welcome to this video on variable equality. So, variable equality, we can think of how to compare two variables in two very fundamentally different ways. The first one is by comparing the memory address, right? As we know, variables are simply pointers to objects in memory, and so we may want to find out, are these two variables pointing to the same object? That's comparing the memory address. We may also want to just compare the internal state of the objects, the data. For example, the contents of two lists. They may not reside at the same memory address, but they may have the same content. And the same thing with strings and number values and all the different objects and data types that we can have in Python. So to compare memory addresses, we use a special operator called is, which is called the identity operator. So to compare two variables, you might say val1 is val2. That will return a Boolean true or false, telling you whether they have the same memory address or not. So remember how we were checking before the memory address, right, by doing ID of A and ID of B and comparing the two and seeing if they were equal? Well, you can do the same thing in code using the is operator, the identity operator, which compares memory addresses. On the other hand, if we want to compare the internal states of the objects, we use the equality operator, which is this double equal sign. Now, be careful, it is not a single equal sign. A single equal sign is an assignment operator. The double equal sign is the equality operator, which will compare the internal state, the data of the two variables. So you would say val1 equals val2. That will tell you whether the contents of val1 and val2 are equal. Now, if you want to test the opposite, if you want to test that the memory address of one variable isn't the same as the memory address of the other variable, then you can use the special operator is not. And that will, you can use it this way. Val1 is not val2, and it will tell you that it will again return a Boolean true or false that will tell you whether those two things are equal or not. Now, you don't have to use is not. If you want, you can just say not val1 is val2. That's one alternative way of checking. But preferably use is not. For the object state, we also have the negation of the equality operator, which is the exclamation point equals. So not equals. Remember that this exclamation point in a lot of different languages also means a Boolean not. Well, here we have not equals written this way, even though in Python the not operator is actually spelled out not, like we have here. And so you would say val1 not equals val2. Now again, there's different ways that you can write this. You could say not val1 equals val2. Okay, so let's look at some examples. So let's say we have a equals 10 and b equals a. So we've created a shared reference here. So let's look at how each of these will evaluate. A is B. Well, that's going to return true. It's a shared reference. It's got the same memory address. But A equals B will also return true because, well, both A and B are integers that contain the value 10. So in terms of values, they're equal. Let's say we look at two strings. Now, this is kind of a special case. If we look at A is B, if you remember the previous video, we mentioned that the Python memory manager is actually going to create a shared reference with this string. So A is B is actually going to return true in this case. But, as we'll see later, do not count on it. So this is why I'm saying in general, when you want to compare the values of two variables, you're generally going to always be using equals. It is rare that you're going to use is, because is comparing memory addresses. So A equals B will return true, and in this case only, A is B will also return true. But if this was a different string, A is B might not return true, so don't count on it. Now let's take a look at two mutable objects. We know that these will definitely be different memory addresses, right? These are mutable objects, so even though we've created them with the same values, Python isn't going to use a shared reference here. And so A is B will return false. However, the two lists are actually equal in terms of values, and so that will return true. And we'll look at equality of lists later because it can actually nest deeper. You can have lists within lists, or dictionaries within lists, within dictionaries, and the equals equals will actually dig down into all those nested data types. So now let's look at this last one, which is a little bit different because a equals 10 and b equals 10.0. So this first one, a, is an integer, but b is a float. So in this case, Python is not going to create a shared reference like we would have if a equals 10 and b equals 10. So a is b is going to be definitely false. And a equals b, even though it's not the same data type, right? A is of type integer and b is of type float. The two values are still actually equal. Python figures that out. It's a number, right? And numbers contain integers and floats and decimals, booleans and complex numbers and so on. And so we'll get the same value. So in terms of value, they're the same, right? 10 and 10.0 are actually the same. We'll revisit floats later because we've got to be a little careful with floats. We don't have exact representations of floats in memory. So in this case we did, and therefore the two values were the same. Lastly, I want to talk very quickly about the none object. Now the none object can be assigned to variables to indicate that they are not set, right, in the way that we would expect them to be. So for example, let's say that we have a variable that's supposed to be a string, but we don't have a value for it yet. So we may set it equal to none, right? In other languages like C, you may think of that as a null pointer, right? You can think of it as an empty value. But nonetheless, this none object is a real object that is managed by the Python memory manager. So the memory manager will always create a shared reference to none. So whenever you assign a variable to none, you know, if you have any number of variables assigned to none, they will all have the same memory address. Again, that's just the Python manager doing that for us, right? It's not creating a new instance of none every time. It's just pointing to the same one all the time. So this means that if we set, let's say, A, B, and C to none, right, then A, B, and C are all pointing to the same object in memory. And throughout the lifetime of your application, it will always point to the same object, to the same memory address. Now, from, you know, as you run your program from one time to another, that memory address may change, but throughout the lifetime of your application, it will be the same. So we can test if a variable is not set or empty by comparing its memory address to the memory address of none using the is operator. So we can test A is none, right? And so this is just something I wanted to point out now since we talked about the identity operator is, okay? So that will evaluate to true. Now just keep in mind, none is not nothing. It's not, you know, it's not nothing. It is an actual object. But it is quite useful in terms of being able to set variables to none to indicate, hey, they don't have a value, right? They do. The value just happens to be none, but that's quite useful, and we'll see that throughout this course where we can use that to good effect. So if we have, let's say, x equals 10, if we say x is none, well, that's going to return false, right? Because x is not none. X is an actual value, an actual object, 10. And if we test x is not none, that will, however, return true, right? That's the negation of the identity operator. Let's start by looking at two variables that are going to have a shared reference. So we can say a equals 10 and b equals 10. Now we know that the Python memory manager is creating a shared reference automatically for us. We can check that by looking at ID of a and the ID of b, okay, which happens to have the same ID. So it's a shared reference, same memory address, and therefore same internal content, same value. So we can print, let's say a is b, and we'll print out the result of a is b. While in this case it's true because they're pointing to the same memory address. And of course, in terms of a value, if we look at a equals b, we'll print out the result of a equals b. Well, we get true as well, which makes sense. They're both 10. Okay. Now let's do something that's not a shared reference. We've seen that in the past as well. We can create two variables. Let's say a and b, both 500. Now the ID of a is that, and the ID of b is something else. right? So now if we want to print, and I'm just going to copy paste, so we'll print A as B, and we get false because, well, they're not the same memory address. However, the values are still the same, right? So A equals B will be true. Okay. Now, same thing. If we have a list, let's say A equals 1, 2, 3, and B equals 1, 2, 3. Well, we know that the ID of A and the ID of B are going to be different, right? As you can see, 168, 416. We've got different memory addresses here. And so the same is going to happen where A is B is going to be false, but A equals B is going to be true, right? Because the contents of the two lists are the same. They're equal. Okay. So the same thing also happens when you're looking at numbers. You can say, let's say A equals 10 and B equals 10.0, right? So again, let's print out this. Then we'll find that A as B is false. Yes, absolutely, because we know that this is an integer, this is a float. Can't be the same object, so they have to have a different memory address. But in terms of values, well, they are equal. 10 and 10.0 are the same number when we think of it logically, right? We can also look at, let's say we have A equals 10, B equals 10. We can even make A equal to 10 plus 0j. Now that's a complex number. If we look at the type of A, that is a complex number, right? And the type of B is a float. So again, here's the results of using memory address comparison, the equality operator, and the identity operator, right? Is and equals. But we can see that in terms of identity, A is not B, which is true, right? Because A is complex, B is a float. But in terms of value, 10 and the complex number 10 plus 0, j or 0i, if you'll use the I notation for complex numbers, are obviously the same value. All right? So next, let's look at the none object. I just want to talk about that. So let's first of all look at the none object, right? It has a memory address, right? Here's the ID of none. It has a type, right? It is an object that has the type none type. So it's a real object in memory. The only thing is that if we have A equals none, B equals none, C equals none, then the ID of A, and instead of me printing out the ID and checking if it's equal to the ID of B, how about I just do A is B, right? That's what we use to check memory addresses. So A is B is true, and A is C. Well, that's true as well. And in fact, A is none is also true, and B is none, and C is none. Okay, all these are true. So it is helpful to use the none operator to just be able to create a variable but not assign a value to it yet, or maybe at some point in time to remove the value that a variable has and say that, hey, it doesn't have anything in it right now. I still want to keep the variable name around. For some reason, I'm going to put something in it later. But for now, I'm going to point it to this none object. And then we can test in our code to see if a variable is set to none. And then we can maybe have an if statement that says, okay, if it's none, do this, otherwise do that, right? So it might be something like trying to read a file, you know, if the file contents exist, if the file exists, and the contents are there, set, you know, A equal to the contents of the file. If the file doesn't exist, set A equal to none, right? And then later on you can check to say, well, if A is none, which means, hey, the file wasn't there, do something, otherwise do something else. So none is used for scenarios like that. But none is an object, but it just happens to be really useful because Python's memory manager will create shared references to that none object. All right, thanks for watching, and I'll see you in the next video.